Hello class, this is Mrs. Gallegos, and this will be a tutorial on how to propagate uncertainty in calculated results. And this is objective 11.2.1 in our IB syllabus, which is called Determining Uncertainties in Results. So propagating error. Rule number 2 tells us when we're propagating error in multiplication or division problems, we're going to add the percent uncertainties. So here's the sample problem. If I have 16.2 plus or minus 0.2 meters, and I'm going to multiply that times 11.8 plus or minus 0.2 meters, and divide that by 2,555 plus or minus 5 seconds, what will be my result? Well, the first thing I'm going to do is I'm going to do the calculations with the measurements. I'm going to get my numbers, my measurements calculated first. So I'm going to multiply 16.2 times 11.8, and I'm going to divide that by 2,555. And my answer is going to be 0.074818. Step 1, the math. Step 2, I'm going to round the answer to the correct number of significant figures. And as you can see, my first two numbers that I multiplied each have 3 significant figures. The number that I divided by has 4. The rules tell us that when multiplying or dividing numbers that are measurements, we take the least number of significant figures. So we're going to put the answer in 3 significant figures, which means I have in this answer 5, so I'm going to knock off the 2 last digits, and I'm going to check the digit next to the last digit that I'm keeping, which is 8. And if that is a 5 or above, I'll round my 8 to 9, and if it is 4 below, I'll leave it. And as you can see, it's a 1, so I'm going to round my number to 0.0748. Step 3. Now I'm going to deal with the uncertainties. I'm going to convert all of my absolute uncertainties into percent uncertainties. The way I'm going to do that is I'm going to take the absolute uncertainty and I'm going to divide it by the measurement. Then I'm going to multiply that times 100 and I will end up with a percent uncertainty. So the first uncertainty is 0.2. I'm going to divide that by the first measurement, which is 16.2, and multiply that times 1. And I'm going to repeat this for each of the uncertainties. Step 3. Now step 4, I'm going to add all of these uncertainties to get a new propagated uncertainty for my new calculated answer. So I'm going to add my 1.23456%, my 1.69491%, and my 0.19567%. And I'm going to get a percent uncertainty for my calculated answer of plus or minus 3.12516%. Step 5. Now I'm going to convert this percent uncertainty back into absolute uncertainty. The way I'm going to do this is I'm going to take the percent uncertainty and turn it back into a fraction over 100, and then multiply that times my calculated answer. So I'm going to take my percent uncertainty 3.12516, divide it by 100, and multiply it by my calculated answer that I did first 2 steps, 0.0748. And that will give me an absolute uncertainty of plus or minus 0.002336. Almost there. Step 6. I'm going to round my new absolute uncertainty to 1 significant figure. So I'm going to round off the 3, the 7, and the 6. If the 3 is 5 or above, I'll round up. If not, I'll just drop it off. And in this case, my new absolute uncertainty is plus or minus 0.002. Next step. Now I'm going to put it all together and add my units. So I have, here's my original problem. And so I'm going to look at my units. Now remember, I have to treat units like numbers. So I see that I have meters times meters on the top divided by seconds. And so my units will be meters seconds over meters squared over seconds. And the way that I express, and we've talked about this, the inverse of anything, so 1 over seconds, will be seconds to the negative 1. So putting it all together, my answer is 0.0748 plus or minus 0.002 meters squared per second. Very nice. Now, I don't know if any of you noticed this, but my uncertainty, let's get up my pointer here. No, I don't want to narrow. My uncertainty is greater, my uncertainty is less certain than my number. So that presents a problem. So I need to have my uncertainty, if you notice, the uncertainty here is in the, get my pad working here. My uncertainty is in the thousandths place, but my number is in the 10,000ths place. And that doesn't make any sense. How can I have an uncertainty that's plus or minus 1,000th, but I have a number that's significant digits all the way to the 10,000ths? So we have to rectify that problem. So step 8. Check for consistency between the uncertainty and the calculated value. And in this case, the uncertainty trumps the calculated value. So what I'm going to do is I'm going to knock off my last digit here. And so now my what happened here is that now I have my last significant figure in my number matches with the plus or minus value of my uncertainty. Now, since I rounded off an 8, I need to go ahead and round this number up to 0.075 plus or minus 0.002 meters squared per second to the negative 1. All right, guys, that's it. That's how we propagate error in problems that involve multiplication and division. And hopefully that's a lot easier than it was in class. Now I want you to try problems, and I'm going to divide them into A partner and B partner. So if you are the A partner in your pair in class, I want you to do this problem. So you're going to take 17.1 plus or minus 0.1 plus 10.1 plus or minus 0.1 and divide it by 15.0 plus or minus 0.5. Notice that we've got a mixture. So we've got an addition problem and a division problem. So you need to first follow rule 1 when you're adding numbers with uncertainties, and then rule 2 when you're dividing numbers. Follow the order of operations, do inside the parentheses first and then outside the parentheses. All right, B partners, same thing. You're going to be doing this problem. Again, you're going to do your subtraction first, then your multiplication and division, order of operations. And remember, there's a different rule for adding and subtracting numbers that have uncertainties. Good luck, and we'll go over the problem in class when I see you next.